So for this particular question, what we want to do is the hint that I would give is, well, there's two things that we need to do in order to prove that this is a right angle triangle. First thing is we need to show that it's got a right angle. So hint is how would you find that there's a right angle in this particular triangle. So I'm not going to write these things down because it'll take too long. But the first thing is, how do we find its right angle? Second thing is, how do we show it's actually a triangle? So to be a triangle, these lines must all intersect at 3 different locations. So that's kind of going to be one thing. So the first thing I'm going to do is show that there's a right angle. So to have a right angle between 2 lines, I'm going to consider the gradients. If I take 2 of the gradients, so let's just call them M1 and M2, if I take the product of those, they should equal -1, and this shows that they're perpendicular. So I'm just going to take A, B, C and work out the gradients each of these. So A, let's just imagine we sketch this. So A is 1, 1, B is 3, 3, and C is 4, 2. It's a bit like that. So it's going to look something like that, and I'm hoping that this is the right angle. So this was A, this was B, this is C. So I'm going to have a look at AB, BC, and AC. So AB, let's have a look. So AB, remember, let's just put these up here so we don't forget. 1, 1, 3, 3, 4, 2. So to get from A to B, the gradient is 3 minus 1 divided by 3 minus 1. Nice and easy. Difference in Y, difference in X. Actually, it wouldn't matter if you got that the wrong way around either, and that's just equal to 1. So nice, easy one for AB. Next, I'm going to do AC. So AC is 2 minus 1 divided by 4 minus 1, which is 1 over 3. Clearly these, if you multiply these, it wouldn't be -1. They're both positive for a start. And then BC, to get from B to C, we're going to do 2 minus 3 divided by 4 minus 3. So this is going to be -1, and the bottom one will be 1. So that's going to be -1. So from here we can see, hopefully, that this first gradient, if you multiply that by this gradient, it's going to give me -1. So M1 times M2 is -1. That shows perpendicular. That's these two. So this means that these are perpendicular to each other. So that's our first kind of deduction from this. So AB, where my pen's gone, let's just get that back. So come on, AB and BC are perpendicular. Or in other words, they've got a right angle. The last thing to note is because, and I'm going to actually write this, because these all have different gradients, it does mean that they're not collinear. So as all lines have different gradients, if I can spell, this implies they're not collinear. And that's the main thing that I want to show here. And this is because if they're not collinear, it means they're not the same line. So if I've got two lines with the same gradient, firstly, they're not going to meet if they've got the same gradient, so they can't make a triangle no matter what I do. But secondly, they could just be the same line. So I could have like from A to B, and then that same line from A to C could just be a longer length of that line. So a little bit like when we look at vectors, but this is just a little bit of the bigger line, so that would mean that they're actually the same line. So because these are collinear, we know they're not the kind of same straight line, and because they're different gradients, they will intersect at different places. So therefore, we've got a triangle.